Så skal vi starte.
Hello, Andreas. You are promised to show us how the wind tunnel is working.
Yes. So
Maybe we. I can start here with the light.
Yeah.
Light here.
Yes.
Sound projection.
Yeah.
And what do? We can see here. Can you explain what do we see here?
The thing we see here is a circular rod that is being tested. Not right now, as the wind tunnel is turned off.
Yeah.
But this is we have tightened the screws here and here, such that this is completely locked to the base plate of the force measurement equipment here.
And so here you can mount your experiment.
Yes. So over here we have all the adapters and stuff for different types of holes, so you can screw a new adapter in if you have a hole that's
And
only
there's
10
tools
centimeters.
here you can use. Yes.
Yeah, if the hole is around 1 centimeter or whatever, then we got the adapters for it.
Okay, starting up the wind tunnel.
Yeah, if you close the door.
Yes, then we have to close the door because otherwise there will be a shortcut of wind inside here. So we have to close the door.
Yes, it's a suction wind tunnel because
Yeah.
it sucks out all the air here.
Yeah.
And the main equipment for measuring speed is located here.
Yeah.
There's a pitot tube connected to a differential pressure measurement device.
Yes.
And the main thing to make sure before you start your measurements is that the National Instruments DAC is both powered, which goes through one of these lines, and that it is connected through the USB cable to the computer.
So we actually have the power supply down here, and it's powered through the USB port.
No,
No.
the PC is powered through this one, and the
Okay.
DAC is powered through this tiny double wire here,
Yeah.
which is the tiny box.
Yes.
All right. So to log into the computer, you use
Yes. We have the password here.
and that is force with a big F, and then 9876, and so on
Yeah.
to 1. And the program that you're supposed to use, that is the latest version, is the Wind Tunnel 2.2. In here, you use the application Wind Tunnel 2.2, and then it starts up. You can full screen it if you like. And all of these channels for communicating with the National Instruments device are set by default, so you don't need to work with those. The main thing you're going to adjust is the pole height, which is the height from the top of the base plate of the measuring device here to the middle of whatever you're measuring. So if it's a ball you're measuring, then it would be the distance from that to the center of the ball.
But this is only a problem if you are going to measure moments. If you only measure force, it just have no influence
Then
in
it
this
doesn't.
whole position here.
Doesn't matter at all.
Yeah.
And then the other thing you're going to make sure you get is that all your measurements are logged. For this, you use an Excel document. Here it's conveniently placed on the desktop. I call it test. So if we open up the program again, we go down here, press this button and find our test document here. Make sure that the path name is to the document that you selected.
And it could also be convenient if you use your own USB stick or key.
Yes, of course. So it's always convenient to save your data on your own USB. And then you're actually ready to start the measurement.
Yeah.
And then you can see that we are measuring some types of forces over here. Those are very small, as we just adjusted it. And if you have not mounted your test setup yet, then you should offset null.
Just before measuring, make a offset.
Yeah.
null.
So you should always remember to offset null after you mounted it and just before you start your measurements. And then it's always handy just to do it, because then it zeros all the values, so we're certain that 0 is 0.
And now I will push a little bit on the rod, and we can see that the force is increasing. And there's also a possibility to see all the forces here. And below is the wind speed, and this is in meter per second. So right now there's there's a very low wind speed. So
Yeah.
so maybe
So
that's
around 0, it sometimes gives not a number because it measures a negative voltage.
yeah. Okay, maybe.
And so now that we've made sure that we offset null, we're actually ready to start the wind tunnel, which is done by pressing the big start button on the dashboard and turning on the knob for whatever speed you want. These marks that are made on the knob are not exact, so you should always be sure to check your wind speeds over on the computer. Now I just aimed for around 10, and we can check what the measurement is over there. If you have
it's around 10 point.
Yeah,
10.3.
Yeah. So if we aim to make a measurement at 10 meters per second, we'd actually be ready to go now, as 10.2 is pretty close to our 10 meters per second. And then I'll just press Excel on when I'm ready to go, and then it lights up on the screen and it logs all the data to a TDMS file on the desktop, given at the location where your Excel document was when we started. And then, okay, now we logged all the data we wanted, so we press Excel off, then it stops, and we can press stop when we're finished messing around with the program. Then we reach the screen here, and of course you should then turn down the knob, not slam it down, but ever so slightly, otherwise the wind tunnel will stop, and then press the stop button so the light will go out. And then we can check the desktop for our measurement file, because that is unfortunately not in our Excel document, which is then this file here, which is named the same but is in another format called TDMS. And for this you can install a National Instruments plugin on your computer so that you are able to open and read these files, which later can be saved as Excel documents, and you can use them just as you want. So I guess that's it.
Thank you very much, Andreas. And then, of course, take your belongings with you and clean. Remember to clean the chamber here. So
it's pretty messy today.
yeah. So good luck with the measurements.